Okay, you don't have to write this down. Just want to see if you can recognize a pattern. Anyone want to take a shot? Sorry? The full answer, please. 25 to the 1 over 2. That, because remember, this means square root, right? But usually we don't write the little 2. I talked about that before. So what does this mean? This means that really this whole time, when you guys were doing square roots, and then last year and this year doing cube roots, any kind of radical, a square root, a cube root, a fourth root, etc., can actually be written using an exponent. Okay? So a radical is just another way of showing a power. Except with radicals, you guys are used to positive exponents, like raising something to the 0, 1, 2, 3, 4, etc. Last year we did some negative exponents, which we'll review again this year. We will review again this year. Okay? But there's also fraction exponents, or what we call rational exponents. So we would say fractional or rational. You hear the word rational a lot in mathematics, and when you see rational, always think fraction, because that's the definition of a rational number. It's something that you can write as a fraction. So we've already seen how to convert. If we've got some radical and some root outside, okay, how do I write that using a fraction exponent? I just did it in those examples. So if I said square root of x or cube root of x, right, it's x to the power of 1 over whatever the root is. So whatever's inside raised to the 1 over whatever the root is. And then, of course, you can go the other way. If I give you a fraction exponent, you can convert it to a radical. I'm not going to prove everything we do today with fraction exponents, but I am going to prove this, okay? Because I think it's important to understand why we can do this. What's the square root of 16 times the square root of 16? 16, because the square root of 16 is 4, times another square root of 16 is 4, which equals 16. Think of your exponent laws. What if I asked you, what's 16 to the 1/2 times 16 to the 1/2? That's an exponent law. What happens to the base when we multiply powers? Stays the same. What do we do with the exponents? When we multiply powers. Add them. What is 1/2 plus 1/2? 1. And what is 16 to the first? 16. Notice these two give you the exact same answer. So therefore, the square root of 16 must equal the same thing as 16 to the 1/2. And you can do that with any example. That's why it works the way that it does. Okay, let's look at a couple of examples. You guys are used to evaluating square roots and cube roots, etc. Like if I give you a square root or if I give you a cube root, you're familiar with it, you would know how to do it. This really doesn't look familiar to you right now. It's like, how do I figure out the answer to this? Well, we just learned, can't I write this as a radical? Because if you can write this as a radical, it'll probably make it easier for you to do. How would I write this using a radical? What number goes inside here? 27. And what's the little number here? 3. So this means the same thing. Now, perhaps this is easier to do. What is the cube root of 27? 3. So if you're asked to evaluate a rational exponent or a fraction exponent, change it to radical because it's more familiar to you. And then you can find the answer from there. How would I write this using a radical? No one? Sorry? Correct. And what does that mean? That means square root, right? And you guys know how to do square roots. Well, this is a decimal. What do you think it is? What's that? 0.7? Yes, because 0.7 times 0.7 is 49 with 2 decimal places, which is 0.49. How about this one? Again, change it to radical form. It'll be easier for you to do. In the radical. And then? What's that? And how do we read this? Cube root of negative 64, which gives us negative 4. We can even do fractions. Still do it the same way. Square root of 4 over 9. And we did these last year. How do you find the square root or cube root or whatever of a fraction? Just take the square root of the numerator over the square root of the denominator, and you get a final answer of 2 over 3. Okay. So notice all those fraction exponents we did, the numerator was 1. What happens if it's not 1? Like what happens if it's 8 to the 2/3? Well, here's what we do. So if we've got, and actually I'm going to do this one first. we've got some fraction exponent where this is not some number besides 1. To change it to radical form, you still put the x underneath. The denominator still becomes the root. But then we have to take this whole radical and raise it to whatever the numerator is. That's the difference. Or you could write it like this. Those mean the same thing. So if I gave you this and asked you to work backwards, that would equal x to the m over n. So let's play with this a little bit. Don't want you to evaluate these. You'd need a calculator to do it anyway. All I want you to do is that first one. How would you write it using a radical? In 2 different ways. Using what we just did above. What would you write? Sorry? Cube root of 40. And then we're going to square it. It's the denominator root of the number raised to the numerator. Or the second way to do it, you can put the 2 right in with the 40 and raise 40 to the second. This is better when you evaluate them. Okay? This is, leave it in this form when we actually get to evaluating them. Okay, what if I asked you to work backwards? We're going to take 2 of these. This one first. How would you write that in exponent form? 2 over 5? Okay, what's the little number here? Yes, remember that's the numerator. That's the denominator. This becomes the numerator. Okay? Or, no, never mind, or. That's radical form. Okay, what if I asked you this one? Cube root 25, and then we're going to square it. Elsie? 25 to the 2 over 3. Good. Okay. So that's how we convert. Remember, a fraction exponent is just another way to show a radical. So we can convert between the two. Kind of like fractions and decimals. You can convert between them. All right, let's take a similar example to the one on the first page, except now all the numerators are going to have numbers besides 1. Again, when you are faced with one of these, change it to radical. So how would I change this one to a radical? Square root of 16, and then I'm going to raise the whole thing to the power of 3. It's easier to do it this way, because if you do 16 to the third and then take the square root, those are big numbers. This you can do in your head. What is the square root of 16? And I have to still raise that to the third. What is 4 to the third? 64. Again, change it to radical and use the parentheses. What does it look like? Right. What is the cube root of negative 27? Negative 3. And remember, when we're dealing with negatives, that's still in parentheses. And we have to raise it to the fourth. So this does not mean 3 to the fourth and then put a negative at the end. This means negative 3 times negative 3 times negative 3 times negative 3. 81, positive 81. See if you can do C. What would you get here when you changed it? Anybody? What goes here? So that means fifth root, 32. And then whatever that answer is, we have to square it after. Now, we haven't done much with the way of fifth roots, but just think about it. It can't be a big number, because what number times itself, times itself, times itself, times itself would give you 32? 2. Has to be a small number. And I still have to square it to get a final answer of 4. And finally, parentheses, need a radical sign. What goes outside? What's the root? 3. This is 1 over 64, and we are going to raise it to the 2. So the cube root of 1 over 64. Well, remember, that is the same as cube root 1 over cube root 64. And we still have to square it. What do we get when we do these two cube roots inside? 1 over 4. And we still have to square it or multiply it by itself. What do we get? 1 over 16. Okay. So a big part of this unit, we're dealing with how to evaluate all kinds of exponents. You guys in middle school and in last year, it was always positive exponents, whole numbers. Then we threw in 0. Anything to the 0 is what, by the way? Remember? Undefined, 0, 1. Which one's it going to be? 0 again, 1 again. It's 1. Uh-oh, we're starting to get confident. What's 2 to the third? 27. 8. What's 2 squared? What's 2 to the first? Every time I drop an exponent, what am I doing here? I'm not subtracting. I'm dividing by 2. That means if I drop another exponent to get to 0, I have to take this previous answer and divide by 2. 1. And that works with any example. Okay? Any power to the 0 exponents is always 1. Oh, How about these ones? -1 for both? -1 for the first one? +1 for the second. Parentheses matter. Because this means you do 3 to the 0, you put the negative on at the end. This means you're taking the 3 with the negative and raising the whole thing to the 0, and anything to the 0 is +1. Just remember that. Okay.